Welcome to Sigma Solver, guys. Before I start the video, I want you guys to smash the like button. This helps the YouTube algorithm and keeps me motivated. And if you are new here, then subscribe to my channel and press the bell icon so that you never miss an update. So without any further ado, let's get started. Machine learning models often begin as prototypes on local environments like Jupyter Notebooks. They are great for experimentation, tweaking, and understanding. But when it comes to scaling these models for real-world applications, the game changes completely. In this video, we are bridging the gap between local experimentation and production-grade deployment. We'll take a machine learning model written in Jupyter Notebook and transform it into a robust system capable of training without human intervention and serving real-time predictions through a simple API endpoint. And to make this transition seamless and scalable, we'll use Vertex AI services inside Google Cloud Platform. Vertex AI provides powerful tools to train, deploy, and manage ML models at scale, all while integrating with the broader GCP ecosystem. So, by the end of this tutorial, you will have the know-how to prepare and package your model for deployment, automate training pipelines, deploy your model as a prediction service accessible via an API, and harness the full power of Vertex AI for real-world applications. So let's dive in and take your machine learning models to the next level. Here are the steps that we'll follow to make it happen. So the first step that you will have to do here is first set up an environment. So in Vertex AI, come to this particular portion called workbench, which is like the Jupyter Notebook, or where the code that we will write will happen, right? So first, this thing is the code part, but we'll come to it later. Before that, put the data inside the GCP cloud storage bucket. In there, I have created this particular bucket called auto detailing, and in that I have the flower photos. Inside this particular folder, we have the entire data set. So we have some photos for daisy, dandelion, roses, sunflowers, and tulips. This I have uploaded, and then what I have done is go to this particular workbench which I have created here, right? You can simply go there by clicking on open Jupyter Lab. You'll land up here. So here what I've done is I have created this flowers folder, and inside that I have created a Docker file, which I'll come to in a bit later part, a trainer folder, and a task.py. So in task.py, you can see that I have a basic image classification model here, which uses Keras, right? So I developed this model, and then I have put the root directory of the dataset as /gcs/auto detailing bucket. In that, I have further down called the data directory as flower photos. It uses that particular data directory to get the dataset and then model itself. Now, after I have written this particular model, so there I go for the containerization of the application we have made here. So for that, outside the trainer folder, we create this Docker file to basically create the Docker container. If you're not familiar with Docker container, don't worry. It's just like a mechanism so that anywhere we can train the model in any of the Google Cloud hardware. So just import from the deep learning platform release of TF2, I imported that, and then the working directory is home inside that trainer, and this is the entry point that I have the task file, so trainer.task. Perfect. Now what I did was I have already stored the data to Google storage bucket, and I have written the training code as well. Now I have created the Docker file. Next, I will build the container. So for building the container, what I did was, if I go here, you see I mentioned first the project ID. So the project ID is what we get here, right? And then I mentioned the repository name. This repository name is for the artifact registry repository that we will have to create for the storage of these containers. Then I created the repository name in this manner, and then I finally built it using the Docker command. So this image got built, and finally I have to push it into the artifact registry. So if we now go here in artifact registry, we will see that inside flower.app we have the flower image.
and it contains the image of what we just built in using this particular command. So after we have pushed it to artifact registry, the third step will be to like use that image to run a custom training job. So for that, what we do is we come down here to training inside model development. Here what you can do is, this is the model that I have trained. You can see it took like 31 minutes and 39 seconds to run that, and like train your own new model based on the data set and choosing the data set and then moving further. Next, there are two particular things that we have to do now. Is like the prediction part can be either done in batch predictions, which is like asynchronous, so they don't require immediate response and more suited for more accumulated batches of data, and otherwise which is online predictions, which is synchronous, low latency, and for small batches of data. For that, what you can do is go to model registry and then import your particular name, and then in model settings, like let's suppose I give it a name, new model, then continue. So here you have to like browse to the particular, like this was the bucket, and when the training will have finished, it will go to this particular model output file, right? So just select this particular model output folder and hit select, and it will create the model registry record for the model that we have actually built from the training dataset. Now, once we do that, we have to establish an endpoint here. Since this is not batch processing, so if it was only predictions, then from model to registered model, which is we have done here, is what we need. But like if we want online predictions, then simply click on these three dots and deploy to endpoint. So if you do that, it will show you what will be the endpoint, what are the settings, the minimum number of compute nodes. Basically, the physical attributes attached to the deployment are considered here, like what will be the machine architecture and so on. You can choose it according to the budget and requirements, and then like you can deploy it. So it will take a couple of minutes and then it will get deployed. So now if you go to the online prediction tab, you will see like your endpoints here. So after that, what I did was like I have actually tested out in this particular environment, which I'll show you right now. This is the testing file that I have made. Is first I imported the AI platform library, and then I mentioned the project number of this GCP project, the endpoint ID, which we will get from here, and then made the endpoint name, and I put the image path as a new testing image which I downloaded from the internet, right? So just to classify it as Daisy, then I put its path here, and then since like we can only have the input in JSON or array format, so I just converted it to float32 NP array. So when I tried predicting it, it like gave a simple error that the size of the request has exceeded the limit, which is fine because like we are not actually concerned with the size of what we transmit. That is what we can change in the deployment settings of like how much time we want it to wait, or like the request timeout period. So this error will not happen, and in place of this we will get like the softmax array of the numbers of like which particular class it attributes to, and it will have like 0.99 values. So that's how you get the data from your JSON files or like photos, and then create the entire like ML pipeline and deploy it, and then also like how you test it out if you have a Jupyter Notebook to do that. So that's been it.
If you still have any doubts, then feel free to reach out in the comment section below. If you liked this video, then give it a thumbs up and subscribe to my channel for the upcoming videos. Till then, happy solving.
Hey there, before you go, I've got some fantastic content lined up for you. Over here, we've got some videos and playlists you might enjoy. But first, if you haven't already, make sure to hit that subscribe button and ring the notification bell so that you never miss out on any of our future uploads. Thanks for watching, and I'll catch you in the next video.